Good afternoon. Something I would like to talk about before you get started in pre-calculus algebra is graphing linear equations. Some of you may find this really easy and you're already super good at graphing linear equations. Some of you may have struggled along the way or don't remember this at all, but you're going to need to know this as you go through pre-calculus. We do a lot of graphing in pre-calculus and it's already assumed you know how to graph points and graph a straight line. So what is a linear equation? Well, the answer to that is a linear equation graphs a straight line. Okay, so if you plot points for a linear equation, it's going to graph, an example over here, a straight line, no curve to it whatsoever. How do you recognize a linear equation? Well, a lot of folks would say, well, it's of the form y equals mx plus b. But the fact is, it's not always in that form. What is common to every linear equation is that your variables have exponents to the first power. So what's going on here is this y is to the first power and this x is to the first power, no matter what side of the equation it's on. It's also a polynomial, which means there's no square roots to deal with. There are no variables sitting in a denominator. So all of these 5 examples below represent linear equations. If you'll take a look at the first one right here, y equals negative 2x plus 1, that is in that classic form that most students remember, y equals mx plus b. We'll talk more about that in just a minute. On the other hand, x plus 3y equals 7 is not in that form at all. The x and y are on the same side of the equation, but notice what's common for both of these is the y is to the first power and the x is to the first power. The x is to the first power, the y is to the first power. That means these would graph straight lines. They have a slope, they have a y-intercept, they have an x-intercept. The majority do anyway. We'll talk about ones that may be missing one or the other of those. Check out this next one. What do you think? Is this guy right here a linear equation? Well, to find out, you ask yourself, is this a polynomial? In other words, no square roots, no x's in the denominator? Sure it is. Is y to the first power? Is x to the first power? You bet. So this is an example of a linear equation. Now where it gets just a little bit on the weird side is right here. Okay, x equals 3, there's no y at all. But that's also a linear equation. Turns out it's a special linear equation that if you graph it, it gives you a vertical line. No matter what y is, x is 3, and so that's what that would look like. On the other hand, this guy right here is missing an x value altogether, but y is equal to 2. It is also a linear equation. Notice the y is to the first power as it should be. If you were to graph this, no matter what x is, x could be anything you want, y is fixed at 2, and that would graph a horizontal line for us. And that'll probably come up again. It'll definitely come up in your pre-calculus class. It's worth memorizing right now that if you have simply x equals a number, that is a vertical line. Love that vertical, don't you? And if you have y equals a number, that is a horizontal line every single time. If you have both an x and a y to the first power in your equation, your graph is going to have a slope. It's going to have an incline to it. Okay? All right, now there are 3 methods to graph linear equations. We're not trying to introduce 3 different things to confuse you. Fact is, some equations graph easier using one method, and some graph easier using a different method. All 3 methods are valuable. You should know how to graph using all 3 methods. The easiest and the first you probably ever learned is simply plotting points. So you select several points to substitute for either x or y, and then you solve for the other variable and you plot those points. You plot the ordered pairs. So you're plotting x, comma, y. We'll do a problem where you get to see that. To me, The most valuable and usually the quickest way is of the form y equals mx plus b, where m is your slope. That's your rise over your run. If we'll remember, rise is up and down, run is left and right, and your b is your y-intercept. Okay, so it tells you right here, b is the y value of the y-intercept. We will definitely graph a line using y equals mx plus b at least one time. Okay, and then finally calculate the x and y intercepts. Okay, sometimes that's the quickest way to sketch a line. The x-intercept is where the graph crosses the x-axis. So if I go back to the top of my screen, top right on my graph, this would be your x-intercept, and right there y is equal to 0. This would be your y-intercept, and right there x is equal to 0. So if you do the math and you manually plug in or substitute x equals 0 to find the y-intercept, and substitute y equals 0 and solve to find the x-intercept, you just plot those 2 points and boom, there you go. Alright, so let's do a few problems where you see all of these methods, and this will prepare you for the rest of your course. Alright, so the first problem we want to look at is y equals negative 2/3 x plus 1. Alright, now if I want to plot points, and this is probably not going to be your favorite method, but you definitely need to know how to do this, okay? Then the best thing to do, I think, is use something called a t-table. And you can either pick your own x's and solve to get y, or pick your own y values and solve to get x. Now the form that this equation is in is y equals. It would be much easier to pick our own x values. And I'm going to tell you the truth, 0 is my favorite. I love to plug in 0 if I'm allowed. In other words, if 0 is in the domain of the equation, and 0 is, so here I go. I've got y equals, I'm just writing the equation down, y equals negative 2/3 times 0 plus 1. Now you all know that negative 2/3 times 0 is 0 plus 1, 0 plus 1 is 1. So I have the point 0, 1 on my graph. So I'm going to plot that. Remember, left, right is your x value, but since x is 0, I don't go left to right, and y is 1. That's going to give me this point right here on my xy axis. Now I could also plug in 1, but y'all look, if I plug in 1, and I'm going to write it down, then I'm going to erase it because I don't like it. It's negative 2/3 times 1 plus 1. Now that's completely doable. Negative 2/3 plus 1 is actually positive 1/3. A calculator that does fractions for you, I'm not going to erase it. A calculator that does fractions for you will tell you that. You should be able to do fractions on your own. To do that, I'd have to find a common denominator by multiplying by 3 over 3. Negative 2/3 plus 3/3 is 1/3. That's where I got that from. If you're graphing on a computer, they're not going to let you graph 1/3. Okay, because it's impossible to get the accuracy correct for a fraction unless they divide your units up into thirds for you. If you're graphing by hand, yeah, we can graph 1/3, so that's 1 comma 1/3. That's about here-ish, right? So keep in mind, if you're graphing on the computer, fractions, not a good idea. If you're graphing by hand, fractions are fine, or you can eliminate fractions by, well, what if I plugged in multiples of 3? Right here. So instead of plugging in 2, where I'm going to get another fraction, let's plug in 3. So that'd be y equals negative 2/3 times 3 plus 1. Now how'd that do me any good? Well, this 3 and this 3 cancel, don't they? So that's y equals negative 2 plus 1, which is negative 1. So we got a nice number, 3, I write it right, 3, negative 1. So 1, 2, 3, negative 1. Now look, I've got 3 points plotted. They all lined up in a nice straight line for me, which makes me feel all good inside, because if you plot 3 points and they line up, then more than likely you did it right. There is a possibility that you could have made an error and it would be the same error on all 3 calculations, but I'm not going to promise you it's right. But if they line up nicely, it's probably right. Now, I would like to revisit this problem, but using the y equals mx plus b method. Okay, so while you're with me, I'm just going to erase this work right here. I'm going to leave my red graph over there so we can compare. And I'm going to do this in a different color. Okay, so here we go. Let's use blue this time. So this time I'm thinking about this in terms of y equals mx plus b. Notice it's already in that form. That means b equals 1 is my y-intercept. That's where it crosses the y-axis. Hey, I'm going to go ahead and plot that point. There it is, right there. Now ignore the red for a minute. Just pretend like it's not there, but I want to leave it there to compare. Now my slope is m equals negative 2/3. Now you have a decision to make. The negative can either go with the numerator or either go with the denominator. It does not go with both, okay? Because a negative over a negative is positive. It can't be both. So it's either negative 2 over positive 3 or positive 2 over negative 3. That's your options. Now, the top number is your rise. So let's just assume we're going with this one. That means we go down 2, because negative 2 is down, and right 3. So from my y-intercept, my blue dot, I count down 2 and right 3. Notice that happens to land on this point. My other option is right here. I could go up 2 and left 3. So from here I could climb up 2 and left 3. Notice all of those points line up once again on that same line. Now to me that was easier than plotting points. Anytime your equation is already in y equals mx plus b, I find that frankly to be faster. Some people get a little bothered if your b is a fraction and you're trying to graph that on a computer. That could be impossible because the computer doesn't like you to graph fractions. But by hand, that's always easier, I believe, to use y equals mx plus b. Now let's do this a third time. Let's do this with intercepts. An intercept method could be kind of rough on this problem, super nice on other problems, but I do want to address it so you know how to handle it. So once again, I'm going to use my eraser. I'm going to keep my two lines, my red and my blue, over there. Remember, they look like they divert a little bit, but that's just my little squirrely pen on my pad here, but they are exactly the same line. So this time, let's find the intercepts. To find an x-intercept, you substitute y is equal to 0. Then you do the math. So I have 0 equals 2/3 x plus 1. Now I'm trying to solve this equation. I need to subtract 1 from both sides of my equation. I get negative 1 equals negative 2/3 x. Remember, the goal is to get the x by itself. Now to do that, I need to multiply both sides by this reciprocal. The reciprocal of 2/3 is negative 3 over 2. If I do it on the left, I'm required to do it on the right as well. Why? Because the 3's cancel, the 2's cancel, the negatives cancel. In other words, I'm left with just simply x on the right. Now negative 3 over 2 times negative 1 is positive 3 over 2. So my point is 3 over 2 comma 0, right? Remember, we plugged in 0 for y. So I go over 2. 3 over 2 is 1.5, 0. That is right here. Okay. Now the other one, the y-intercept, in this case is going to be easier. We're going to let x equal 0. So I'm moving on to my next calculation. Okay. So I have y equals negative 2/3. I'm removing the x and replacing it with 0 plus 1. Okay. That's just 0. So that means y is equal to 1. Well, lo and behold, we knew that already from the other times we graphed it, right? But I connect these two dots, and again, I get the same line a third time. So it's not that, you know, you have to know 3 ways to graph, but some problems are easier to do one way and some are easier another way. This one was already in y equals mx plus b, which to me is the fastest. Alright, so for this problem, negative 2x plus 5y equals 10. Now maybe we should focus on picking the quickest way to graph. Now y'all, the intercept method in this case looks fast. Notice it's not in y equals mx plus b. So you're not going to quickly find the y-intercept because there's no b value to be seen. You'd have to solve it for y. But you know, 10 divides by 2 and 5 easily. The intercept method is the way to go here. So what I'm going to do is first time I'm going to let x equal 0. And remember, that finds the y-intercept. That's worth memorizing today, okay? Because we have to find intercepts all the time, not just for straight lines, but for all types of graphs. So to find a y-intercept, you always, 100% of the time, let x equal 0. So you do negative 2 times 0 plus 5y equals 10. Well, you know this is just 0, which means that's just gone, right? So that gives me 5y equals 10, which gives me y is equal to 2. So that's the point 0, 2. I'm going to plot that point. It's right there. Okay. To find the x-intercept, I'm going to let y equal 0. Okay. So that's going to give me negative 2x plus 5. I'm substituting 0 for y is equal to 10. Again, 5 times 0 is 0, but that's just gone. That gives me negative 2x is equal to 10. I divide both sides by negative 2. Y'all all know that 10 divided by negative 2 is negative 5. I plot that point. That's negative 5, comma 0. So that's right here. I connect the dots, make a nice straight line, and I am done with that graph. Now check this one out. Weird, isn't it? Like it's missing things. But it's not. It has an x and a y. Which remember on slide number 2, we talked about as long as it has an x and a y, it's got some kind of slope to it. Okay, it's going to have some kind of angle going on. It would be real fast just to do a t-table on this and plug in a couple of points. How about 0, 1, and 2? So you're doing 4 times 0 is 0, right? 4 times 1 is 4. 4 times 2 is 8. So I'm going to plot 0, 0, 1, 4, and 2, 8. I connect the dots, and there's my line. Now, what if you didn't see it that way? What if you're thinking, that looks to me like y equals mx plus b? Or does it? So 4x plus what's b is 0. There's not one there, right? So that means my y-intercept is 0. Here it is. My slope is 4, but I got to write that in fraction form, right? So that would be up 4 and right 1 from my y-intercept. So I count 1, 2, 3, 4, right 1. I could even do it again. 1, 2, 3, 4, right 1. And I ended up with actually the same exact points that I did the first time. That was just coincidence. Okay? And you could even find the intercepts. But here's the deal. If you find the intercepts, you're going to get 0, 0 both times, so you're going to be stuck. You're going to have to use another method for this. So this is one where the intercept method would kind of fail you because it's only going to give you 1 point, 0, 0, because the x and y intercept are the same. But the other two methods are real easy. All right. Whoa, okay, right. Y equals 4. Now remember the last page, we had y equals 4x. Notice the difference. Last page, y equals 4x. That means there's some kind of angle because it's got a y and an x. This page, y equals 4, you're missing an x altogether. All right, so this isn't in y equals mx plus v form. You could do that, but what I want you to do is have it memorized that this is a horizontal line. Now, if you were to do a t-table, let me show you. Here we go. Now, you're supposed to be able to pick one side and solve to get the other side. Well, there's no x's at all. Which really means it seems like you couldn't pick for x, but x can be anything you want, anything, because there's no x at all. But what's y? 4. Every single time it tells you right there y is equal to 4. Well, if you plot the point like 1, 4, 2, 4, 3, 4, 8, 4, 25, 4, you're going to get a horizontal line. So here's 1, 4, 2, 4, 3, 4. Anything 4 is going to give you that line right there. So even if you forget it's horizontal, you can plot points and figure that out on your own. Whoa, next guy in line, x equals negative 2. Again, something's up, right? We know it's linear because it's x to the first power. But we also know something's up because it's missing a y. Okay, so you either have memorized, just straight up, that this is a vertical line. Well, what if you forget? Okay, that's fine. Here's what, no matter what, x is negative 2. I don't care what y is. It could be anything you want. X is negative 2. So you could plot the point negative 2, 1, negative 2, 0, negative 2, 8. It doesn't matter to me. X is negative 2. So here's negative 2, 0. Here's negative 2, 8. Here's negative 2, 1. No matter what, that is going to give you this vertical line. Now, I think it's worth memorizing that x equals is a vertical line, but if you don't, plotting points is the way to go. All right, x plus 4, y equals 7. What do you want to do? Okay. if you use the intercept method, remember the intercept method is when you plug in 0 for 1. Well, check this out. What if I plug in 0 right here for x? So it disappears, but then you get y is 7/4. Do you see that without me writing it down? Because you divide both sides by 4. Now, on paper, that's fine. 7/4 is 1 3/4, and we're good to go. On the computer, not so good, because you can't graph 7/4 on a computer because they don't want any approximations. Okay, you're not guessing kind of where 7/4 is living. So I'm thinking the intercept method is not your best bet here. I am trying hard to erase. There we go. Okay. What I am thinking is maybe y equals mx plus b, and then you're like, it's not in y equals mx plus b form. Well, you can certainly put it in y equals mx plus b form, right? What if I subtract x here and I subtract x here? Why am I doing that? I'm subtracting x once on each side of the equation. Totally allowed. Those properties of equality. I got 4y is equal to, now I can write this as 7 minus x, or I can remember y equals mx plus b format. The x comes first, so I'm going to write it as negative x plus 7. Then I'm going to do the last step and divide everything by 4. Each side of the equation, which means each term. So y is equal to negative x over 4 plus 7/4. Well, look, I still got the same issue, don't I? Now, maybe you won't have to graph this on the computer, or maybe you might have to spend some extra time finding some whole numbers to graph, which would mean a t-table. But let's get this over with. I'm just going to graph the 7/4. Okay, now remember we talked about what that was earlier. This is your b value, right? It's where it crosses the y-axis. So 7/4 is 1 3/4. Calculator will tell you that's 1.75, whatever makes you feel better. I'm going to put it right here. Best approximation I can do on this kind of scale. Now my slope. Now we know it's over 4 and it's a negative. What's right there? Y'all know there's a 1. So that means I'm going down 1 and right 4 from my intercept. Then you think, oh no, I got to count from a fraction. Oh, come on, you can do that. So down 1 takes me there, and then down 1 again takes me here. Okay? You might not have seen that movement at all. So again, I'm at 1.75. That's 0.75. That's going to be negative 0.25. So right here, and then right 4. 1, 2, 3, 4. Yeah, I don't know if you could see all those little dots I was making as I was counting. I could do it again. I could count down. I counted down 2, didn't I? Ooh, let's undo that thought. My bad. What am I doing? Okay, ignore that. Let's try this again. Let's count down 1. So if I count down 1, y'all, that's right here. I counted down 2. I don't know why. 1, 2, 3, 4. So you're at 4.75. And I count down 1 again. So down, my 4.75 disappeared. Let's try that. I count down 1, 1, 2, 3, 4. Now I'm at 8, negative 0.25. And I connect the dots. So the point of this problem, other than that silly mistake that I made, is that it's not always nice, okay? But you need to come up with a graph. Hopefully the homework problems on the computer will be something you can graph, and they are. I haven't run into one that was impossible to graph just because it was fractions, okay? All right, last review problem, although you probably still need lots more practice. We've got graph the line with y-intercept 0, 3. So y-intercept 0, 3, and slope, which we call m, 3/5. Okay, this is actually easier than the other ones because you had to pull this information from your graph. So y-intercept 0, 3, so I plot the point 0, 3. There it is. And then m is 3/5. That means I rise up 3 and right 5. Hey, let's do that. So up 3. 1, 2, 3, right 5, 1, 2, 3, 4, 5. Remember, don't count the place you're at. When you're counting, you don't start where you're at, right? You start at the next one. So I'm at 3, but no, I don't say 1 until I get to 4. So 1, 2, 3, and then don't start 1 there. 1, 2, 3, 4, 5. Okay? Now, would it be okay if I went down 3 and left 5? Is that all right? Well, sure it is, because that's the same as negative 3 over negative 5. Those two negatives cancel to give you positive 3/5. So that's totally allowed. So I could do that too. So down 3, 1, 2, 3, left 5, 1, 2, 3, 4, 5. And that gives me that point. And notice they do all line up in a nice straight line. And there you go. I hope this review helps. If you're very unfamiliar with graphing straight lines, you may want to spend some more time on some problems like these. Come see me, work through Newton and get some more practice problems, whatever it takes. Let's get this done, and I promise you'll think the rest of the class is easier because you knocked out this pre-course review. Have a great day.